All right. Hello. Good morning. So I didn't really prep anything for this, but I had like this mental image that I thought could set us off. Because we've done a lot of exploration now. Like, what's the minimal? Well, let's actually draw this mental image I got. So if you imagine, like, you don't even have to imagine it. You can just look at it here. Let's see. So you have like this line. And then you have React here. So you have React here. And this line represents like state complexity. Maybe we should do. So we have React, and then we have state complexity moving along this line. And the thing is, then we have this other line. That doesn't have an arrow. How do I turn off that arrow? Okay. And this is like, this represents going external. Like that. So the point, let's give it a color. Okay. So the thing about React is, even in the documentation, right, it states that when state complexity reaches a certain level, you can look at like external state management libraries like Redux or whatever. And what we've been pushing is like, what's like the absolute, so let's imagine this is the, well, actually it's like way down here. Like you kind of immediately have to go external with React. If you do any kind of like, one thing is data fetching. You can get very far with React query if the complexity is only data fetching. But when it comes to like actual state management in the client, and you have a very complex UI, let's call it state UI complexity, it very quickly breaks down. And then we did this, so let's, we're gonna actually draw this. Okay, and then we have, so this is like the old, and this is not like very scientific, but what we kind of did with the, let's call it, yeah, let's put that in. So use React signal. What it tried to do, at least, can I put that between here? Use React signal. It kind of pushed that point, right? Because we're gonna look at, I started doing some refactoring of the family Scrum app to kind of see it in practice, and I have some like thoughts on that. But the point is that we were able to like push that line down, so you can manage more state and UI complexity just using React. And why would you want to do that? Well, the thing is, like, going external has a cost, right? Even though it becomes simpler to manage state and UI and like the state of complex UIs, let's just call it state complexity, so there's no confusion. There's like a cost to this, and it depends on what external library you use, what that cost really is. So for example, a cost of using MobX is that you will now have these like functional components, and then you have object-oriented class-based state, right? You have immutability in your components, you have mutability in your state. And I'm not saying that, like, in my experience, it differs extremely from developer to developer how comfortable they are with that shift. So if you are comfortable in both domains, then it's like it's perfect, right? Because then you can express yourself in the best possible way doing state management, and you can express yourself the best possible way deriving that state into UI using components. But for many developers, that's what happens is that you have this mutable, it doesn't even have to be class-based, right? It's just a mutable external state store. And they start doing things they do in React, like they don't push to an array. They concatenate to the array and replace the array. So you're kind of losing the benefits of going external. Yeah, so there's like another like point here, which is like, what should I call it? It's literally like, this is another how should I do this? Like, this is not like increased state complexity. Well, okay, we're gonna run with this. So at some point, the state complexity, so you can go, okay, this is interesting. So going external, you can do things like Redux, for example, maybe like sush. Well, yeah, maybe Sushdan. Is that? Yeah, anything that's like still immutable, right? Still in the immutable space. Yeah, so we're gonna have another line here that we're gonna call mutable. So let's make this blue. Let's make this, I don't know, red. And then let's stretch this. Because there is a point where Redux, Sushdan, and Jotai doesn't work either. And an example of this is, what if you have an array of objects and you're making a lot of changes to the items of these objects in this array? If you use a mutable approach, first of all, you can express that change so much better. But also, if you make a change to, for example, the count of one object in an array of 100 objects, the only component actually looking at that count is going to reconcile. And this is a huge deal, because what normally happens is like, it changes the reference of the item itself, and then it changes the reference of the array. And then if this is some nested state, it changes the reference of the state branch, and then up to the root of your state. And this causes like a ton of reconciliation that you don't need. And it very quickly becomes a performance issue. So here you have like MobX, you have this Bonsify thing we worked on. Let's do, yeah, let's just call this mutable. How should we do this? State complexity. Yeah, something like that. Where was I going with this? Yeah, so the thing is, like, I think my point is that it's very, very hard to look at your application and then like, where am I on this spectrum? Yeah, that's what I want to talk about. Where am I on this spectrum? What's the right library for me? And what I was hoping is that we could have like a more clear separation. So if we could make React more performant for state management, I think, yeah, so what I want to say, let's see. Can I just copy all of this? There we go. So if we could make, okay, one more line. So we're going to delete that one. Okay. So this is kind of the world we have now, I think. And then what we did is that we kind of pushed React, that like the moment of needing to go external, we kind of pushed that. And how far? I have no idea. But let's say we pushed it over here just to make my point. So the space of actually needing these libraries and evaluating which one of them you need becomes smaller, right? Because now you can actually just use React much farther. And what I would hope to see is like, not like going external, but just going mutable. Because mutability is the thing that separates, should be the separator, I think, ideally. Because the reason you use these ones is because React isn't performant enough. It's not like React itself that's a problem. It's just because it's not performant enough. I guess, well, like I'm just throwing stuff at the wall here. Of course, it's not only because React isn't performant enough, but it's like, it's the main reason, right? And then they apply their like preferences on the abstraction, like the signatures of changing state and so on. Using concepts like store and stuff like that. But at the end of, but that's kind of the problem as well. Like, what if you didn't need those abstractions? What if you could just use hooks and contexts, right? And then if you're building a very complex application, right? So React can just handle everything. It's at the point where you truly have like a single page application that's immensely complex, that you need mutable state. You need, what do you call it? Surgical updates, right? That's when you go external. Yeah, I don't know. But I think my point here is that it's very hard to navigate the React space in terms of how to do state management, because React is so bad at doing it. And then there's so many levels of complexity where each tool is built for their experience complexity of state management, right? Even Redux wasn't even built based on, Redux was based on just a theoretical way of doing things. It wasn't even based on like building a complex app or anything like that. But I would expect like Surstand and Jotai to be very much that, coming out of actual like building apps. I know Mobix is definitely that, and all this stuff I've been working on, like Cerebral and Overmind and stuff, that's also definitely coming out of building very complex apps. Oh, did we put Jota here as well? And yeah, it's just very difficult to navigate all this stuff. And for me, it's like, it will be much easier for me to identify just looking at an app, like, okay, should we use, so my preference would be like, okay, I want to use React, but it just stops, right? Because of performance issues. Like you can't efficiently use context for state management. But looking at an app, it's more like, it's not even about the app, it's more like about the team. Like, do we have a team of developers that knows React really well? Well, they can adopt to React Signal, that's for sure, because it's the exactly same thing, or exact same thing as use state. But when you come to like introducing Mobix or like the reactive primitive from Bonsify or whatever, then it becomes something else. Then they have to buy into mutability, and that might not be the right choice for the team. And what's interesting about Bonsify, it's not really about, like when I say Bonsify, this is really just some patterns. I should just call it reactive. And then it's like, it's very interesting. Like it's so, there's so many axes here. It's like, even when you look at like Redux, Surstand, and Jotai, they have like these abstractions of stores. But when you look at something like Preact signals, it doesn't have a concept of a store. It's just primitives, right? So they don't guide you in how to organize. these primitives. So there's like a different kind of solutions as well. Yeah, I'm not sure where I'm going with this. But I think like I have minor points there in this soup of reflections that make sense. But it's very hard to like create some kind of consistent image of all of this, I think. So yeah, so like from my experience, what I've noticed is that I've been in a startup where we use like one of these libraries I built called Cerebral, which is definitely on the far end here. It was a very complex app. It was mutable, and the developers that worked on it were very junior developers, and we had to like buy into something that was accessible to use, and it was accessible to use, but they learned Cerebral, right? They didn't learn JavaScript, or they did with time, but we needed to, as a startup, we needed to move fast, and it worked, right? It was actually a big success. Like it was one of the defining moments in the history of the startup, was like us choosing to change the tech stack and choose tools that was accessible to the resources we had available to us. So that's like really important. But then I've also been like at Code Sandbox, using like the successor to Cerebral Overmind, which had the same mutable ideas. And then we hired React developers, and I started seeing like, but they're not they're not doing it mutably. They don't kind of get the mental image of this. And not because they're bad developers at all. It's just because they have a React mindset. And I'm not saying React mindset is wrong. It's just different. But the React mindset has some downsides. One thing is performance, like you don't have surgical like updates. But also the fact that it's very hard to express state and the functionality to change that state in a simple way, because you have to split them up. Like that's best practice, to split up functions from the state. But in a mutable paradigm, you want that functionality as close to the state as possible, and that is a big bonus. It makes it so much more discoverable and so much easier to express what is this app? How does it work? What can I do? What can I not do? But it's such a different paradigm. So, yeah. Yeah, maybe we should do some coding. We didn't actually conclude with anything here. This was just a bunch of thoughts. But to me, that's like, yeah, I'm thinking about like, I'm doing some interviews these days. And I think that's like, if you're hiring a React developer and you're using like some kind of mutable state management tool, you should really ask them if they have experience with it. And if they don't, onboard them properly to that mindset. Yeah. Yeah, I think, you know what? I think what I really want here, I want to have one solution that works in React, and I want one solution that's just the bare simple minimum going outside of React. That's what I personally want, because I want to be able to work in a team where we choose to use React and it will actually work. because I had that experience building version 2 of Code Sandbox where we embraced React and it didn't work. We had so much performance issues, and just organizing the state was horrible because we depended on context. But at that point we had that experience of building version 1 where we had that like mutable problem that the developers wasn't able to adapt to that mental model. So that was also a driver for us trying to embrace React again. So I guess that's the thing. Like instead of looking at the app, look at the team. What are their like skill sets and their preference in programming? Because you can solve the same problems like functionally and object oriented. Like this is about preference. Yeah, so maybe we should jump into the code because maybe it's easier to. So, okay, so I have these two solutions, one embracing React, one going external. And in here, I started doing some refactoring. So it was very similar to the other reactive thingy we did, only now we're just using the signal. So what I liked about this immediately, I should maybe have done this refactor during the stream, but when I use the signal now, I could just shove the state in there. While previously when we used the reactive thing, I had to have an object with a state property because of the way this state changes. But now I can actually replace the signal itself, like set session, which I couldn't do before. I had to change keys on the object to be able to make changes to the state. But now the signal itself is the state. So that was really nice. But one thing that's problematic here is that I'm creating state with functions. And this is considered bad practice in React. And I think that's kind of what I'm left with after trying this, is that I love the idea of doing this. You have state and you express what can you do in this state. Like I'm not talking about explicit states, I'm just talking about state in general. You have some piece of state and there's a way for you to interact with that state. And that's like goes through typing and discovery and everything. I really like that. I think that's a much better way to do programming than separating state and data over here, and then you have functionality over there. It's very hard to figure out what fits with what and how you compose things together, and just discovering all the things. They're like, these things are literally in different files. They're not like if you do external, you have a single object where you just explore everything. So whatever you point to in a component, you have access to all the state. You can just point, like dot your way around and find stuff, right? But if you don't do that, if you separate state from functionality, you have to start, okay, I need to import some type from some data persistence file over here. And I have to import like some function over here, and then I have some state here. Like it's just very, very difficult to reason about. And so this is the thing I just don't like, because if we were gonna do this like best practice, yeah, exactly, from the people who created hooks in a function. So yeah, so the thing that kind of, yeah, so you kind of lose some of the benefit, really, because some of the benefit here is that this session object this reference will never change, right? That's the power of this. That's what makes it performant, is because this session will never change, the reference, but its value will change, right? So if you attach methods onto this, onto the value, then those, oh, wait, yeah, sorry. No, I'm putting this the wrong way. Well, okay, sorry. So if you put methods on the session here, those methods themselves, they won't change reference either, right? Because whenever you update the session here, if I were to update the reason, for example, I would keep the same reference to sign in, right? Because I will kind of do a spread on the state, and then I would just update the reason. So everything kind of keeps its same reference. But that's going against best practices of React, and that bothers me with this approach. Because you're still in this kind of shitty. Let's see, I have another example. So for example, we have use family scrum here. And it looks very nice, right? I'm building up a context here. I'm just exposing everything, and it's perfectly fine. Because the only time family scrum provider reconciles is if it's unmounted. So it's perfectly fine. But that's also a thing that's hard to reflect on or realize here, I think, is that why can you just pass an object here? That's not best practice. You should use memo, right? Because if family scrum provider reconciles, then this object becomes new, a new reference, and then all consuming components of the context will reconcile. But I know that this component will never reconcile again. Because if it does, it means you change your authentication status, which means that it unmounts. So you kind of have to have this like very internal, deep understanding of, and maybe that's fine. Maybe that is fine, but it bothers me. And if I go into one of these, it's the same thing. Like again, what I like about this is that I'm separating the state from, so now I'm co-locating functionality with state. So I actually like this because now I'm co-locating state and functionality by returning it from the hook. So I'm not putting them into the same object in useSignal or useReactive, but I'm putting them in the same scope. And what happens then is like, so for example here, I can just reference set groceries, for example, and it just updates the groceries. And it's clear that this is a signal, this is functionality. But again, I just returned this object. Yeah, so using this with impact. Yeah, exactly. So the problem is this object. It kind of, I don't know how to communicate that. Because, yeah, I don't, because what we're trying to do is like the minimal thing, the minimal change to React to gain as much performance as possible. But when you go external, you just completely solve performance, right? Because you don't have to think about reference changes at all externally. But now that we're doing this minimal thing, there's still an issue with references, but it's reduced a lot, right? So the question becomes like, what is this thing? Is it trying to solve React's performance issues? Or is it just trying to, like we explored here, is it just trying to push the boundary of when you have to go external? Like it just makes it more performant, but you're still gonna hit an issue at some point with some complexity. So this is just how you use it. So you just use it the way you do best practices of React. You just return the object here. If you're concerned about this object reference causing issues, you can use a use memo there. That's a best practice from React. People already do this. But now we made that such less of a problem that you're less likely to have to do that. So that's kind of the message here. Is like with use signal, you don't have to memoize unless there's like extreme circumstances. But one problem is that even though groceries doesn't change its reference, these do. All these functions change the reference on every render. So if you were to like pass I don't know. Yeah, I just want to say, I think that has to be the thing you embrace. It's like, okay, by using use signal and then dot value, like groceries dot value, like you dot value things, you will get more performance and you can live longer with React. But at some point, if you get into performance issues, you need to go external. And that's the thing I hate about React. It's like, what if it just didn't have state management at all? Or it only had, well, of course it needs context. Of course it needs some state, right? Because some of it is like animations and stuff like that. But maybe just this hard cutoff of like, if you do any kind of state management beyond UI, you have to go external. Like that's the hard cutoff. Maybe it's like just a fool's errand to try to make React work for state management. So yeah, so this is the thing that bothers the hell out of me. It's that we still have references that are recreated, but I don't know the impact of that. I know it's less of an impact because, for example, here we have the family Scrum provider. I know, I just stated, I know that this only reconciles once. So this object only exists once. The groceries object only exists once. Like these hooks will only run once, unless strict mode, of course. So I know that, and it won't be a performance issue. And that, I think that is the story of providers. Is that with this use React signal, providers will actually reconcile only once. They're more likely to unmount than actually update. But having to know that, because so another example would be if you have like a counter, for example, right? And then you have some, or counter state, for example. So you have the state of the counter here, and then you have the actual counter here, and then you pass state, right? So what if this, or you do something like this, count and then increment. So count is the signal and increment is the thing that changes the count. So if you do this, and for some reason, like you also have the count value here. So every time you increment the count, Well, yeah. Or let's put it like this instead. Or even better, something that's actually so increment. So you're passing the function of incrementing down to some component. So when I click increment inside counter, it's gonna render counter state again. But it's also gonna render counter again because increment will now change its reference because increment is defined here, right? And that's the thing that bothers me. The state and the functions for handling that state doesn't behave the same way. That's the thing I don't like. But if you did count, set count, use signal, and you would use an object here with count 0 increment. Yeah, whatever. So here, maybe this will be counter instead, set counter, whatever. So if you did this instead, increment, but then you would have to do like counter value dot increment, which I guess is fine. Value count. Then this would keep its reference. This would never change. But this is also kind of weird, right? So there is a different way to think about this. It's to do something like use signals, for example. And that takes an object, and now you have count. And now you can actually do counter.count, because internally this is a getter for the value. So each key becomes a signal. So you kind of hide the dot value thing. And now you can also argue that increment should be here. But now we have a different problem, because how does increment point to the mutable version of this? Well, maybe it could do, yeah, set counter. Yeah, maybe that would be fine. So yeah, because what I was thinking about is that it would look like this. But you can still do this. So you have set counter, and then with set counter, you actually have, this is the mutable reference, right? Because this is the whole thing. We want to, if you build something like this, just like use state, you have the readable, read-only value, and then you have the mutation function. And you want to keep that mutation function inside the scope of the component. So the component controls how that state moves forward. And I didn't think about it this way. I was thinking about it like in here, but yeah, sometimes it's good to. So this would solve it for me, because now, first of all, you don't have to use the dot value all the time. And we keep mutations, or not mutations, but we keep changes inside the thing. And we can even do like a partial update kind of thing. So you don't actually have to do this thing. Like what you do here is partial updates anyways, right? Because you're changing a specific one or multiple signals. Like this would not fix, for example, the use session. Because here we have different objects and we're using like sign in here. But that's more to a pattern of state machine than anything else. But yeah, so this could definitely solve it for me. Because now you can do like, you can do increment, you can have increment here. You can say set counter, count, counter. counter.count +1. That's fine. Let's implement that. Because this is also, yeah, okay, so we're gonna implement that just for fun. And then there's one last thing, and that is inside, okay, let's remove all of this. So I used to have 2 memos in here, but I couldn't have them here anymore. And the reason is because when I use memo inside this provider, that memo will actually reevaluate every time I was looking at to-dos and dinners. So that memo would reevaluate every time I change to-dos and dinners, which means that if this one reevaluates, any consumer would reevaluate. So I had to move those memos to the week calendar. So I moved them here. So here I have derived week dinners, derived week to-dos. So here I have the memos. But it works as it's supposed to. Like what I wanted to memo is that when you move between the slides, like changing the actual slide index, we shouldn't recalculate all the days, right? They should only recalculate if you actually change a dinner or a to-do. So this does its purpose, but that means that if you use a provider, you shouldn't be using memo inside them. But memo is really to derive UI, complex UI state, right? So I think it's fine. Yeah, so that's the only thing that I kind of picked up on. But if you do it like externally, like you can like cache. Well, the problem here is that use memo doesn't actually just make things dirty. It actually reevaluates when it sees the value change. It's not based on, okay, when you pull the value out. But I think computed is a very misunderstood concept when deriving UI. Because if you have a heavy computation, you don't want to perform that calculation as you render the UI. You kind of want that, don't want to flag it as dirty. You want it to update it at the optimal time before you extract it in the UI, I think. It's very interesting, but that's a whole other thing. Anyways, let's play with, by the way, I think I have a session at 10. Is that true? Let's see. Yeah, I have a session called, funny enough, Let's Solve State Management. Okay, let's move over to Bonsify. Not Bonsify, but the use React Signal. I did update the documentation though. It's kind of cool how it looks now. Where is the... Look at this with emojis and stuff. Yeah, but maybe it will be better with use signals. So instead of use state, you have use signals. Yeah, I think we should pivot. Let's pivot. Use React signals. I guess there's an npm package called I don't care. Yeah, nobody took that. With use signals and say goodbye to performance gradual of replacing use state with use signals. Share state through props or context without performance challenge assignment or model for updating state and using effects and memoizing. That's true. Simple implementation that you can read and understand. That's also true. Okay, so we're going to change the signature of... I also want to go through the implementation, actually. Let's see if we have time for that. So let's say we're going to export use signals. And now this needs to extend a record of string. We can just do extends. Okay. And then if it's the server, we are just going to return. We can actually just return the value. Oh, that's also interesting. We just return the value as is. Or if you try to change something, we throw an error. Okay, I'm officially quite excited about this actually. So signal needs to, okay, we still have signal. So what we want to do now is we want to go through the keys of the value. Let's see. Can you help me? No, wait a minute. We want to do this in a different way. I think we should just create signals. Let's just create an object as t. And then we're going to go through for key in value. This is not true. We're going to do object defined property signals key get. We're not going to have a setter. You don't understand what I want to do here, do you? So we're just going to keep a closure of the signal. S. So we're creating a signal out of this. So this will be S. How are we going to do this? Wait a minute. We need to keep how are we going to do this? Okay, we're going to do, let's see. First, we're going to do signals and let's just create them. Let's see, sorry. If and value key and type of value key is not equal to function, then we're just going to add this signal. And when we have those signals, what we want to set as the thing here is the getter. Getters would be, yeah, let's just do, this is signal. Yeah, and then const setter. Yeah, okay. This is what it's going to be. So we're going to go through. We're going to set the signal there, and then we're going to say getters key or object define property getters key get s. Okay, let's do setters. We're going to do setters and getters. Okay, now I know what we're going to do. So first we're going to have getter setter. Okay, this is nice. And then we can say, well, for setters, we can just do key equals setter. And for the getter, we have to create an actual getter. So getter.value. Yes. I'm not sure what it's. Oh, define property. There we go. Okay, so now we have the getters. So now we can return getters and setter. And setter is going to be, we're going to fix the typing here, but the setter is going to be a partial of the actual keys here. That's not functions. So let's just call it partial. We'll fix the typing here. Just want to do the implementation. Yeah, exactly. This is exactly what I want. I'm not sure why I have to do this has own property. I don't think that's necessary. These are plain objects. Yeah, and this is just going to set the signal. Yeah, this is exactly how it's going to work. So what I want to do, I want to create like a proper creator for this. Create signals. So this is going to take the same thing. Well, so let's call it create signals. This is going to take the value, and then let's put this in and get the typing in order here. So these setters are going to be, well, this is horrible with typing. I think maybe I'm just gonna not care about this. These are internals. And then this is gonna be return getters setter. Yeah, the only thing we need to handle is the actual. Yeah, let's just do any here because this is just too complex. And this is not going to be, the signal tuple is actually not going to be anything like this. It's not, it's going to be T, and we're going to call it signals tuple. Well, sorry, we're going to export a new type here. Signals tuple. Partial, but this partial is actually only going to be things that are not functions. So maybe we can ask, this partial should exclude keys that are functions. Thank you. Signals tuple. Cool. This is it. Yes, I think this is actually it, because use React signals, because what happens now is you're gonna do use signals, and it's gonna be count 0, and then we're gonna have counter, and set counter, counter.count plus 1, and this will be counter.count. Yes. And you could argue you can have both, but I don't think so. The whole point here is to make useState more powerful. So and that's also a thing that annoyed me. Was like, oh, but I have these local component states that uses use state. Why would I ever use signal there? And like you don't need to, but it becomes like a conflict of which one should I use? Kind of like preact signals. It's kind of weird to use signals inside a component. Except they have this like super hyper surgical thing where you can like put a signal inside some piece of text and only the text actually reconciles. You know what? We're gonna actually add increment here. Just immediately point out and then counter.increment. Just immediately point out why you would want to use this. Because it's not just the count, it's that you can add functions there as well. So yeah, this is good. With use state, unlike use state managing only a single, unlike use state managing only a single value, and decoupling functionality from the state, use signals allows you to define multiple, well, this is going to be confusing because of course use state can have how are we going to explain this? Decoupling values from, how should I explain this? Unlike use state, use signals requires an object. The reason is that each key becomes an isolated signal. How should I explain this? Like, it makes a lot of sense from a technical perspective, but like from the perspective of use state. Okay, use state is great for local component state, but when you want to share state, either through props or context, use signals. Yes, that's exactly. Use signals. It requires an object where each key represents a signal. You can also add methods. It is also encouraged to include methods. It is also encouraged to include methods. As the result of this is non-changing. As the result of this is state management that never changes references. that only triggers reconciliation when the accessed signal changes its value. Yes, scale up your context for accessible set without worrying about performance issues. So again, use signals. Again, here you would do like use signals, counter, set counter. And the cool thing is that like here again, you can use like this constructor pattern thingy, set counter. What was it? Counter.count plus 1. And now we just expose the counter and everything's protected. You can't change each key because it's like a getter, it's read only. It can only be changed through set counter. Perfect. El perfecto. With signals, there will be far less changes to props, context, references that trigger reconciliation. This is because signals are passed by reference and not value, which means the same signal instance means the same signal will pass to child even when the okay, so this we have to change this a little bit. Let's see. With signals, there will be far less changes to props, context, references that trigger reconciliation. This is because I want to keep that line. This is because the object returned by use signals never changes. The functions never changes reference either. Changes reference. The functions never changes reference either. Only accessing, the only way reconciliation can trigger is by a component accessing a key, a signal key. The only way reconciliation can trigger is by a component, is when a component accesses a signal key. And yeah, exactly. The result of this is isolated and predictable reconciliation. The plugin will transform your application components to observe signals and prevent reconciliation waterfalls with memo. With a minimal implementation of signals and observation, the application will be more performant and waste less memory due to targeted. And now there is no cost. Great. So what we're going to do, just to explain how this actually works, we're going to do new file signals, and we're going to, let's see. Use signals. I'm going to put that in here. Export function create signals. Signal. Oh, it's server. Oh yeah, we need that 2 different places. File utils. Export consts. Yeah, and this should be, let's first export, use signals from signals. Then we have the observer, export observer from /observer. Using external store. Cool. Yes. Come on. Okay, I have to go shortly. I would love to like actually try this, but yeah, whatever. So we can still have export type signal. No, well, we don't actually need to export that anymore because it acts just like values, right? So you don't need to dot value into anything. Yeah, and then cool. You cannot change signals on the server. This is awesome. Let's see. Let's see. Okay, so we have the index file here. And you have this observer. So let's just comment. This is automatically imported using the plugins. A server. And then we have the observer component. We create a new observer context for each. Oh, but is this correct? Start tracking. I think this needs to. Yeah, we need to clear the signal notifier. Oh, that's interesting. Yeah. Oh, that's actually a bug. Yeah, because dynamically you might change what signals you're looking at. So and the observer context is responsible for tracking, for tracking signal access during component render. We start tracking. We set up only after tracking we actually subscribe to the signals. This is important for memory management in concurrent mode. Or we could risk not disposing subscriptions. This only notifies about the change. We then grab the current snapshot, which is the global number for any change to any signal. And we'll always get a new snapshot whenever a related signal changes. Even though impact is not designed to run on the server, we still give this callback as, for example, Next.js requires it to be there, even when rendering client-only components. Yes, exactly. Do I need to ignore that? No. We always stop tracking. after rendering to ensure we do not pick up on any other signal access outside the scope of the component. It's like, it's super, super clean now. I'm very happy about this implementation. So that's the observer. And then it's using an observer context. Use for memory leak debugging. Console log. This global counter makes sure that every signal update is unique and can be tracked by React. This is instantiated by a signal. Is it? Wasn't it by a context? Signal notifier. Oh, yeah. Let's change the signal. This is instantiated by a signal to keep track of what observer contexts are interested in the signal and notifies them when the signal changes. This is, when is this created? I can't remember. Oh yeah, so okay. Every signal created has a related signal notifier. This signal notifier is responsible for keeping track of keeping track of what observing what components basically are currently accessing the signal. When the signal changes, it will notify all contexts, well, all components. Yeah. Every signal created has a related signal notifier. The signal notifier is responsible for keeping track of what components are currently accessing the signal. Observer contexts. Maybe I should even change the name of this. Are currently accessing the signal. When the signal changes, it will notify all related components. This is done by keeping a set of observable context. A signal holds a global snapshot value, which changes whenever the signal changes. This snapshot is passed and stored on the observer context to make sure React understands that a change has happened. And add context, remove context, notify. A context can be synchronously added back to the signal related to firing the signal, which could cause a loop. We only want to notify the current context. This has hit me many times with event systems, that you fire off an event that kind of resubscribes to the thing, and it just keeps going in the loop. So this can probably be optimized a little bit, but this is like, yeah. The observer context is responsible for keeping track of signals accessed in a component. Yeah. Didn't I say every single has a, yeah. Yeah. So the observer context is responsible for is responsible for starting for tracking, for managing the contexts for signals to track access to them. The observer context is responsible for managing the context Okay, the observer context is used by components. Okay, every signal, every component has an observer context. When the tracking starts, the context becomes the active context in the system. Any signals getting the value, any component retrieving a signal value will register to this active observer context. The component then subscribes to the context, which will add the context to every signal tracked. When context is notified about a change, it will remove itself from current signals and notify any subscribers of the context. It is expected that okay, let's see. Every component has an observer context. When the tracking starts, when the component starts tracking, the context becomes the active context in the system. Any component retrieving a signal value will register to this active observer context. The component then subscribes to the context, which will add the context to every signal tracked, allowing it to notify these contexts when the signal value is updated. When the context is notified about the change, it will remove itself from the current signals and notify any subscribers of any subscribing components. It is expected that the subscribers of the context it is expected that will in the the subscription, when a component unmounts, the subscription is disposed. This will remove from any tracked signals making sure that component store unmount component unmount will also remove the context from any signals, making it prime for garbage collection. We track all signals accessed yeah, an observer context only has one subscriber at any time. Yeah, we don't need this stack trace. Components are using which expects a snapshot to indicate a change to the store. We use a simple number for this. We start out with the current as it reflects the current state of all signals. Use for memory leak debugging. Start tracking. We clear out existing signals as dynamic UIs might track different signals now. Deactivate this context if it's the current one. Register. Yeah. When adding a subscribe, we ensure that the relevant signals are notifying this observer context of update. That means when nothing is subscribed to this observer context, the instance is free to be garbage collected. React asynchronously subscribes and unsubscribes, but user-sync external store has a mechanism that ensures the validity of the subscription. So this is important. Like the reason we can do this, so everything's very React specific. So the reason we can safely track signal access in a component during rendering and then asynchronously subscribe to it is because the useSync external store has this get snapshot. So synchronously during rendering, it's going to go and grab the snapshot. And then when it asynchronously starts subscribing, it's going to check if the snapshot is the same. And if it has changed in the meantime, it is going to reconcile again. Like, who knows this shit, right? Took me forever to figure that stuff out. And it dictates so much how you need to do this. So if there's a previous subscription, we don't need to clean anything up as we're just replacing the callback function. Make sure all tracked signals have this context registered. Return unsubscribe function. Yeah. Clean up by removing this context from all. Yeah, and I guess we can also say this dot. We can clear the signal notifiers. When a signal updates, it goes through its register context and calls this method. Here we always know that we get the very latest global snapshot as it was just generated. We immediately apply it and React will now reconcile given it is subscribing. Oh, we also clear it here. Yeah, okay, so we actually, yeah, so we cleared it on notify instead, but I think it's better to do it on start tracking. Yeah, no, I think it's fine to do it. Okay, so yeah. Cool, but that's basically the implementation. It's exceptionally straightforward. And the signal itself is just a function that creates a signal notifier. It creates the getter. Yeah, we could even simplify this now. We could make the signal getter just a function. Yeah, let's do that. So this will be, yeah, we don't even need signal now, I think. So that's signal getter. Yeah, sorry, let's call it function signal getter. And then we have signal setter. Yeah, it has an update signature, but we don't actually need that now. We do nothing if the values are the same. That's good. And then we change the value, we notify the context, we have the signal getter, and here now we're gonna do getter instead. Cool. Okay, so I have to jump into a session, but we're gonna test this as soon as I get a chance. Yeah, but this is exciting. This is very exciting. Cool. Let's do another stream where we kind of wrap it up, test it, wrap it up. We can look at family scrum, how it looks, reflect on the things that concern us with just use signal, and then yeah, and then ship it. Cool. Bye for now.